previous two terms. Add y to wait, so this is
your favorite
N1 is 1, and 2 is 10.
I think it's supposed to be Gauss. I call him Gauss. I mispronounce everything wrong. I really do. I used to call Panera bread forever. Panera bread? Just always. I think I'm recording this. I should probably stop. Raise your hand. Tell me, what is the pattern that's happening in this top thing? Zach, what's going on? Yes, the previous two numbers. So, for example, the third term, which is 2. So if I kind of look at this number 2, it's equal to the previous term, which is 1, plus the one before it. Now, one way I could look at that, you see how I've labeled my terms as A1, A2, A3, A4. We looked at how to do that in the previous section. So I could label this as the third term is equal to the second term plus the first term. This is what's called the Fibonacci sequence, and we're really looking at how you can generalize this sequence with what's called a recursive formula. This basically means that one term in the sequence depends on all the terms before it. So the Fibonacci sequence for a recursive formula could be defined as any term is equal to, you could put A1 first if you wanted to, like if I wanted to call this A1 and this one A2. Then it would be a to the n minus 1 plus a to the n minus 2. And what you have to recognize is just what these pieces mean. So this is the nth term. A to the n minus 1 is the previous term, and you can see how if you plug in an actual value for n, how that works, even in the one above it. And then n minus 2 would be the one before the previous. One before the previous term. Now we're just going to be looking at really the nth term and developing it off of the previous term. Last night's homework, you were looking at how do you find the explicit formula or the nth term of any sequence. Fibonacci does have a formula that could generate any term in this sequence. It's very complex. It's very complicated. You will never be asked to do something like this, but just for the pure genius of what he did, let's write down what the formula is that can find any term. Fibonacci, he's amazing. He's genius. So his formula is any term in this sequence, which is the Fibonacci sequence, can be found by taking 1 over the square root of 5 and multiplying it by, show it gets better, 1 plus root 5 over 2 raised to the n plus 1 power minus the quantity 1 minus root 5 over 2. Probably not long. Most genius mathematicians, it's just like they just take things quickly. Raised to the n plus 1. Totally can relate. Oh my gosh. How does he get it? It's very, very complex, and you're not required to know it. So you can put in a star. You do not need to know this. I just wanted to show you the genius of what's behind these numbers. You do not need to know this.
About a lot of other things in math. You do not need to know.
You do not need to know that formula, but he's genius. And we're actually going to be looking in what's called the binomial theorem in section 9.6, how you can use the Fibonacci sequence and just be looking at different things with it. Okay. All right. So for today's purposes, let's focus on what you need to know for how to use a recursive formula. Is it a question?
About Fibonacci.
Yes.
Has all like the math discoveries been discovered? Because it seems like every time like you hear about discoveries, like some guy from
the ancient, many things that we've built on are from ancient times, but no, new math formulas and discoveries are being done all the time. I mean, if you if you think about just the technology advancements we have even over the last 10 years, it's because of mathematicians building and finding and creating, and I mean architects go into it too, but there's constantly new discoveries being made. Good question though. A lot of the things we teach in school is based off of discoveries from a long time ago because we know they work and we believe you guys can handle the material made from them. And we know that, which helps too. So, but it doesn't mean that you're discouraged from keeping to try to find new things. All right, guys, let's see how we use this. All right, I need you to regroup. Max up here. Emma up here. Okay, let's see how we would use this. Find the first 5 terms of the recursive sequence defined by A1 equals 1. That means the first term has a value of 1. So we know the first term. To find the second term, I would be looking for 3 times. Now notice, I plugged in n equal to 2. So when I'm looking for an minus 1, it would be a2 minus 1 plus 2. What is 2 minus 1? 1. So I'm really looking for 3 times the first term plus 2. What is the value of the first term? 1. I can see that in the instructions. The first term is equal to 1. Trying to get a different color there. So I'm going to plug in 1 for the first term, and that tells me that the second term is equal to 3 times the quantity 1 plus 2, which is 3 times 3 equals 9. So the first term has a value of 1, the second term has a value of 9. The third term is going to equal 3 times, now I'm plugging in 3 for n, so it's going to be the second term plus 2, or the previous term. So that would be 3 times, what was the second term's value? 9, so I'm adding 9 plus 2, which gives me 11. 3 times 11 tells me that the third term is equal to 33. Fourth term, I'm looking for 3 times the previous term. What would be the previous term to the fourth term? The third term, plus 2. It's equal to 3 times, what was the value of the third term? 33 plus 2. So I have 3 times 35. Yep, equals 105. Just to clarify, sometimes I'm surprised, well, I didn't learn this till later, but it's a really nice, helpful trick. I'm sure you've been taught this before. But as a quick reminder of how to multiply something like this without your calculator, remember you do 3 times 30. What's 3 times 30? 90, and add 3 times just 5. So what's 3 times 5? 15. So what's 90 plus 15? 105. So that's how we know our answer was equal to 105. Just in case you forgot that or weren't taught that. Let's do the fifth term. The fifth term is going to equal 3 times the fourth term plus 2. So what was the value of the fourth term? 105 plus 2. It's going to equal 3 times 107. Try to use the trick. What's 3 times 100? 300. And what's 3 times 7? 21. So 300 plus 21 tells you that the fifth term, is not that. Is, sorry, 321. Okay, so we found the first term, second term, third term, fourth term, fifth term. With your partner, see if you can do it again for the next example. Terms, the first term is 1, second term was 1/6, third term was 1 over 36, or you could have called that 1 over 6 squared. The fourth term was 1 over 216, or you could have called that 1 over 6 cubed. And the fifth term was 1 over 1296, or you could have called that 1 over 6 to the 4. Now, this is one where we could actually generalize and kind of like Fibonacci, we could find the formula for the nth term. What would it be?
1 over 6.
Yes. 1 over 6 raised to the n minus 1 power. See how that works with the number 1. If I look at 1 over 6, the value of n is 1. What's 6 to the 0 power? 1. So it becomes 1 over 1. This one is 1 over 6 to the first power. This one is 1 over 6 to the second power. This one's 1 over 6 to the third power. And this one's 1 over 6 to the fourth power. So you can, in certain cases, be able to generalize what the nth term is. But for tonight's homework, the main goal is to be able to use the recursive sequence. Okay. All right, guys, your homework